How AI voice synthesis works. Imagine hearing a voice that sounds just like Morgan Freeman or your own best friend, but it wasn't them speaking. It was AI. That's the power of voice synthesis. Today, AI-generated voices are narrating YouTube videos, voicing audiobooks, powering virtual assistants, and even replacing actors in movies. But how does it actually work? Let's break it down. AI voice synthesis is the process of generating human-like speech using machine learning. At its core, it converts text into speech that sounds natural, expressive, and context-aware. There are several stages to this process. It starts with the most basic, text-to-speech, or TTS. Traditional TTS systems, like the robotic voices you might remember from early GPS devices, used concatenative synthesis. This involved piecing together pre-recorded audio snippets into full sentences. But while this was functional, it didn't sound human. Enter deep learning. Modern AI voice synthesis uses neural networks, specifically deep learning models like Tacotron 2, WaveNet, FastSpeech, and VITS, variational inference text-to-speech. These models don't just stitch sounds together. They learn the patterns of human speech, intonation, rhythm, pauses, and even emotion. Here's how it works, step by step. 1. Text input. The system receives raw text. 2. Linguistic analysis. It analyzes the text for phonetics, prosody, the rhythm and stress, punctuation, and context. 3. Spectrogram generation. A model like Tacotron 2 converts the processed text into a spectrogram, a visual representation of sound. 4. Waveform synthesis. Another model, like WaveNet or Hi-Fi GAN, takes the spectrogram and generates raw audio waveforms. This two-stage process creates voices that are astonishingly realistic. But what about cloning a specific voice? That's where voice cloning and speaker adaptation come in. Voice cloning uses a few minutes or even seconds of someone's speech to train a model that can mimic their voice. The more data you have, the more accurate and expressive the clone becomes. There are two main approaches. Speaker embedding. The eye learns a vector, a set of numerical features that represents a speaker's unique vocal traits. This vector can then be used with a general TTS model to generate speech in that voice. Fine-tuning. The model is directly trained on the speaker's recordings, tailoring the output to match that voice exactly. Companies like 11 Labs, Resemble.ai, Descriptors Overdub, and Microsoft's custom neural voice offer advanced voice cloning solutions. But with power comes responsibility. Voice synthesis raises major ethical and legal questions. Can someone clone your voice without permission? Could AI be used for deepfake scams, voice fraud, or misinformation? Absolutely. That's why many platforms require explicit consent from the original speaker before cloning a voice. And some, like Microsoft, restrict access to their tools entirely to vetted partners. Voice watermarking, a technique to embed inaudible digital fingerprints into synthetic voices, is being developed to combat misuse. But even watermarking isn't foolproof. So where is this technology going? In the near future, AI-generated voices will become more interactive. Instead of reading scripts, they'll respond in real time with dynamic emotion, adapt to audience reactions, and even reflect regional dialects. Multilingual voice synthesis is also growing. Some models can now clone your voice and speak in a different language without you ever learning it. Beyond entertainment, AI voice synthesis is opening doors in accessibility. For people who've lost their voice due to illness, technology like this can give them a synthetic voice that still sounds like them. In education, it can create custom narrators tailored to learners' preferences. In gaming, it can enable procedurally generated voice lines, creating dynamic, personalized dialogue. And in virtual reality, it's key to building believable, reactive characters. Still, the line between helpful and harmful is razor thin. AI voice synthesis challenges our sense of authenticity. If a politician says something controversial, but it's AI-generated, how do we know what's real? That's why media literacy, regulation, and transparency are essential. As creators and consumers, we need to ask, who made this voice? Was consent given? Can it be verified? Because the technology is neutral, but how we use it, that's up to us. So if you're using AI voice tools, get consent for cloning, disclose when a voice is synthetic, protect your voice data, respect privacy and IP laws, and if you're building these tools, add safeguards, prioritize detection, design with ethics in mind. AI voice synthesis is here to stay. It's transforming how we communicate, tell stories, and experience content. And done right, it's a powerful tool for creativity, accessibility, and innovation. But it must be used with care. Because when voices can be generated by machines, truth becomes harder to hear. And that's why understanding how this technology works and how to use it responsibly is not just for engineers, it's for all of us. Welcome to the future of speech. Let's use it wisely. Let's go deeper into the technology behind AI voice synthesis. Tacotron and WaveNet. A powerful pair. Tacotron 2, developed by Google, converts text into a MEL spectrogram. It learns linguistic features, including how we naturally change our pitch and timing when we speak. But Tacotron alone doesn't produce audio. It just creates the roadmap. That's where WaveNet comes in. WaveNet, developed by DeepMind, takes the spectrogram and generates the actual sound. It models raw audio at the waveform level, one sample at a time, producing incredibly realistic audio with minute details of human speech. But these models are computationally expensive, so researchers developed alternatives like FastSpeech. Speeds up training and inference time by removing the dependence on recurrent neural networks. Glow TTS uses normalizing flows to create more controllable speech. VITS combines text to spectrogram and spectrogram to audio into a single end-to-end system using variational autoencoders. These innovations drastically reduce the cost of generating synthetic speech, making it more accessible. Ainsi, real-time AI voices. In 2024, we're seeing the rise of real-time voice generation. Instead of pre-generating audio, some tools can now respond in milliseconds, adapting tone and speed dynamically. This is revolutionizing customer service bots, AI companions, and interactive learning platforms. Real-time AI voices are also being used in virtual meetings, translating your speech and maintaining your voice, but in a different language. Imagine speaking English while your voice speaks fluent Japanese on the other side. It's science fiction. It's deployment ready. Training a custom voice model. If you wanted to train your own AI voice, Here's what you'd need. 1. High-quality recordings of your voice, usually at least 30 to 60 minutes, more for high fidelity. 2. Transcripts for alignment. 3. A TTS architecture, like Tacotron 2 or FastSpeech 2. 4. A vocoder, like WaveGlow or Hi-Fi GAN, to convert spectrograms into audio. 5. GPU resources, to train the models, which can take hours to days, depending on size. Open source libraries like Mozilla TTS, Koki.ai, and ESP.NET make this process more accessible to researchers and developers. But as cloning becomes easier, so does the risk. That's why legal and ethical frameworks are racing to keep up. Who owns a cloned voice? If you train an AI model on someone else's public YouTube videos without their consent, is that theft or fair use? Courts haven't caught up yet, but lawsuits are coming. Meanwhile, governments are beginning to act. The EU's AI Act includes clauses about deepfake transparency. China now requires disclosure when synthetic voices are used in media. And the US Federal Trade Commission has begun investigating AI misuse cases involving fraud and impersonation. So what should you do? If you're a business using AI voice synthesis, disclose it clearly to your audience. Get written consent for any voice cloning. Track and store voice data securely. Don't mislead, ever. If you're a consumer, be skeptical of what you hear. Verify sources. Advocate for transparency in synthetic media. And if you're a developer or startup in this space, build for integrity, not just speed. Make watermarking default, not optional. Allow users to detect, not just generate. Voice it is identity. It's emotional, personal, powerful. And now, thanks to AI, it's programmable. But with that power comes the responsibility to protect trust in communication. Because if we lose that, we don't just lose credibility, we lose connection. So the next time you hear a voice online, ask yourself, is it real? Is it responsible? And more importantly, can you tell the difference? In the AI era, voice isn't just what we say, it's how we shape reality. Let's do it wisely. Final thoughts. AI, voice synthesis, is one of the most fascinating frontiers in modern technology. It blends computer science, linguistics, psychology, ethics, and art. And like every powerful tool in human history, it reflects who we are. It can entertain, educate, empower, but it can also deceive. So we need creators who build with conscience, policymakers who move with urgency, and users who engage with awareness. Because the question isn't whether AI voices will shape the future. The question is, who will shape the values behind those voices? Let it be us. Let it be now. Let it be done right. Welcome to the new sound of intelligence. Let's keep it human.